Hey guys, welcome back to the channel. Today we'll be looking at a higher order thinking skills or H.O.T.S question from chapter 10 of CBSE class 10 mathematics, which is circles. And this is a very essential topic for term 2. So let's get right into the question. The question states that a point P is 13 centimeters from the center of a circle. Find the length of a tangent drawn to the circle from point P if radius is 5 centimeters. Okay, so now that we understand and know the question, let's get solving. From the question, we are able to discern a few things. First of all, we have a point P which is 13 centimeters away from the center, and the radius of this circle is 5 centimeters. Step 1 is to always draw a diagram, because a diagram visualizes the question and allows us to solve it quicker. And usually the evaluators award at least 1 mark or 0.5 marks for a diagram. In this diagram, I recapitulated everything that's part of the question. So we have a circle with radius 5 centimeters and a point P which is 13 centimeters from the center, which is O. And we also have a tangent drawn from point P, which is PQ. So we know the values of OP and OQ, and we're trying to find the value of QP, which is the tangent length. So now that we've drawn our diagram, the next step is to write down the given values and required to find values. So the given values are the values that are provided in the question. So through the question, we were able to derive the radius of the circle and the distance between O and P. So over here we can write down OP is equal to 13 centimeters and radius, which can be denoted by R, is equal to 5 centimeters. Now that we've written down the given values, we have to write the required to find values. And this includes the essence of the question. What are we trying to find? We're trying to find the value of QP, or the length of the tangent. So over here we can write PQ, and in parentheses we can write length of tangent. Length of tangent. So now that we've drawn the diagram and listed the given and to find values, we can start with the solving. We'll begin by citing a theorem from the textbook, Theorem 10.1, which states that a tangent is perpendicular to the radius of a circle at the point of contact. So here the tangent is PQ, and it's perpendicular to the radius OQ. And we always have to write down the reason behind this statement, which is Theorem 10.1. Always write the reason in parentheses. So, if PQ is perpendicular to OQ, that means that angle OQP is 90 degrees. The theorem states that the tangent is perpendicular to the radius of the circle. So, that means angle OQP is equal to 90 degrees. And we can write that down here. PQ is perpendicular to OQ. Therefore, angle OQP is equal to 90 degrees. What's next? Since the figure OQP closely resembles a triangle, and it also includes one right angle, we can state that triangle OQP is a right triangle. And essentially, a right triangle is any triangle that has one right angle, or one angle whose value is 90 degrees. So, if we recall the triangles chapter, we can also implement Pythagorean Theorem. And the Pythagorean Theorem states that the hypotenuse value squared is equal to the sum of the adjacent side and the opposite side squared. So in other words, the hypotenuse here is OP squared is equal to OQ squared, which is the radius, plus PQ squared. And this is based on Pythagorean Theorem. Basically, C squared is equal to A squared plus B squared. Pythagorean Theorem. The last step is to substitute our values. So we know that OP is equal to 13 OQ is equal to 5, and PQ is the missing value. So we can write 13 squared is equal to 5 squared plus PQ squared. And we just simplify this. 13 squared is equal to 169, which is equal to 5 squared is 25 plus PQ squared. And if we subtract 25 from both sides, we get 144 is equal to PQ squared. To find PQ, we have to find the square root of 144. So root 144 is obviously 12. So the value of PQ is 12. And don't forget the units. Here we're using centimeters. So we've determined through solving that PQ is equal to 12 centimeters. And that's our final answer. Be sure to underline and do not forget to mention the units. So after all of this meticulous solving, we were able to determine the length of the tangent. We were able to find our value, which is 12 centimeters. So that is today's video. I hope you enjoyed. As always, thank you so much for watching. For more step-by-step explanation of these complex math problems, whether it be standard, higher order thinking skills, or even advanced, be sure to comment down below. We were able to solve it by writing down the given values, two find values, and a neat solution. And we finally derived our answer. So every math problem, especially in a subjective exam, has to be enlisted in this exact format: diagram, given, to find, and the solution. So thank you so much for watching, and until the next video, it's H.O.T.S signing off. Peace.